So we'll talk about experimental research. So again, remember, when we talk of experimental research, this is the only type of research that can test hypotheses to establish cause and effect relationship. No? So don't forget that when we talk of experimental research, it's the most familiar type of research designed for individuals in the physical sciences. But as of the moment, we are actually using it for educational researches like for action research. But remember, what you will submit for methods of research should be very different from the action researchers that you are doing in your school. Because the action researches, though the research design being used is experimental research, but there are so many characteristics compared to educational research or your thesis proposal na very different from the action researches that you are doing. When we talk of experimental research, we're actually talking about the question, what if? No? We have to consider that the researcher would be manipulating the independent variable and measures the dependent variable. So there will always be two groups. But sometimes considering the research design that I'll be discussing later on, you would see that we will only consider one group that will be given the treatment and the post-test. Sometimes post-test will only be provided to the experimental group and there will be no control group. Then the independent variable is controlled or set by the researcher, and then the dependent variable is measured by the researcher considering the tool that you would be using based on the research design that you will choose. So these are the types of experimental research. As you can see, it's only focused on single variable designs. Because when we talk of multiple variable designs, then another types of experimental research will be utilized, which is factorial design. And we would be using two-way ANOVA or multivariate designs in the analysis of the data that we would be gathering. So as for today, let's just focus on the three research designs, particularly the types of experimental research, which is true experimental design, quasi-experimental design, and pre-experimental design. And under the true experimental design, as you can see, we would be discussing pre-post-test control group design, the post-test only control group design, and Solomon 4 group design. So observe that the Solomon 4 group design later on would be the combination of the pre-test, post-test control group design and post-test only control group design. And we have the quasi-experimental design, the non-equivalent control group, time series, multiple time series. And we will try to differentiate true and quasi-experimental research. And then finally, the pre-experimental design. But I would like to discourage you to use this. And later on, you would understand the very reason why I'm discouraging you to use pre-experimental design for your proposed thesis or your thesis. So experimental research would be very familiar or is the most familiar type of research design, particularly for action researches, no? And for individual in the physical sciences and education. This is mainly because experimental research is a classical scientific experiment that we are very familiar and similar to those performed sometimes uh, in your SIP or your science classes, but considering different characteristics. Here in experimental research, remember always that it should be a scientific approach to research where one or more independent variables are manipulated. So as of the moment, we are considering single variable design. So we would be focusing only in one variable, okay? Because it could be two or more. And that is another type of experimental research, which is factorial design. The effect of the independent variable on the dependent variable is usually observed and recorded over some time to aid researchers, okay, particular you, in drawing reasonable conclusion regarding the relationship between these two variables. Take note that when we talk of experimental research, you always avoid relationship in the title. Hopefully, you were able to read my video clip in the YT channel in order for you to know the titles suitable for experimental research. But there are so many ways na to indicate, but those are the basic titles that can be utilized for experimental research. Take note that the discussion for today should be focused on educational research. But of course, in medicine, we can apply experimental research, but considering very high degree of reliability, because sometimes in medicine, we are actually talking about human beings. So again, there are three types: pre-experimental, quasi-experimental, and true experimental research. As for the pre-experimental research design, let's talk about the general differences. Uh, in pre-experimental research design, either a group or various dependent groups are observed for the effects of the application of an independent variable, which is presumed to cause change or to improve performance of the students, particularly when we talk of intervention or strategies that we would be utilizing in order for our students to master the lesson that we are teaching. It is actually the simplest form of experimental research design, and it's treated with no control group. There should only be one group when we talk of experimental research. That's why I'm discouraging you to use this. Why? If you use one group only, you use the treatment and then you will compute the scores using a particular statistical treatment, then there is a possibility of internal and external invalidity. Although very practical, experimental research is lacking in several areas of true experimental criteria. So I'm referring to the pre-experimental research. Okay. So the pre-experimental research design is, as you can see in the presentation, divided into three parts. So let's talk about one-shot case study research design. Later on, you might be able to realize that they are almost the same, but there is only one difference, and we'll go into that later. In this type of experimental study, one shot case study research design, only one dependent group or variable is considered. One group is considered. The study is carried out after some treatment which was presumed to cause change, making it a post-test study. Then after that, after providing the treatment to the experimental group, you will provide them again. We will provide them immediately with the post-test. Then one group pretest post-test research design. This research design combines actually both, as you can see, post-test and pre-test study by carrying on one test on a single group. Again, single group still, but pre-test and post-test will be given before the treatment is administered. When I say treatment, that could be intervention, that could be strategies that can be used considering educational perspective and after the treatment is administered. So with the former being administered at the beginning of the treatment and of course the post-test will be provided at the end, di ba? Pre-test before, post-test after. And the static group comparison, in a static group comparison, there are two or more groups. No, two or more groups are placed under observation where only one of the groups on the given groups is subjected to some treatment while the other groups are held static. Okay, it could be two or more, but then there will only be one experimental group. The others would become control group. All the groups are post-tested and the observed differences between the groups are assumed to be a result of the treatment immediately. Next, quasi-experimental research design. From the word itself, quasi, it means partial or pseudo, or therefore um, quasi-experimental research being a resemblance to the true experimental research, but they are not the same. It's it's like before true experimental research, because there is a missing piece when we talk of quasi-experimental research design compared to true experimental research design. Because here in quasi-experimental research design, the participants are not randomly assigned. Therefore, in true experimental research design, randomization is being employed. So this is actually a common educational research where administrators are unwilling to allow the random selection of students for experimental samples. For example, the principals and even the parents, no, do not allow you to do randomization in selecting control and experimental group. Then you might as well use quasi-experimental research. But of course, there is a resolution or solution to that problem, particularly if the sectioning in your institution is heterogeneous. No? Heterogeneous sectioning, then you can actually identify one to be part of the experimental group, and the other section would be part of the would be the control group. The only concern if you are using homogeneous sectioning, because actually you cannot compare section 1 to section 2 in homogeneous sectioning. Of course, section 2 would be better than section 1 is better than section 2 if your sectioning is homogeneous. The quasi-experimental, as you can see, we have the time series, non-equivalent control, the counterbalance design. For true experimental research design, this relies on statistical analysis to approve or disprove a particular hypothesis. It's actually considered as the most accurate type of experimental design because because randomization is being employed. So therefore, the true experimental research design must contain, again, a control group, a variable that can be manipulated. No, the control group is the variable that the researcher manipulates, and the distribution must be random. Therefore, in identifying the control group and experimental group, randomization should be done. Random numbers should be given to students. Okay, so there are so many ways to do that, like computer generated, no, or it could be fishbowl technique, where the researcher provide random numbers to the students, and then you pick one for control, then you pick another one for experimental group. The post-test only control group design, in this design actually, the participants are randomly selected and assigned to two groups, of course, the control and experimental group. But only the experimental group will be given the intervention or the treatment. After close observation, both groups are post-tested, and finally, towards the end, the conclusion is drawn from the difference between the groups, no, the control and experimental groups. For pre-test and post-test control group design, the participants are randomly assigned to the two groups. Both are presented, but only the experimental group will receive the treatment. Then after observation, the two groups will be post-tested. to measure the degree of change, whether the aim is to have a significant difference in the result. So again, no, the first two of the groups or these groups are tested using the post-test only method, while the other two are tested using the pre-test post-test method. So the post-test only control group design and then the pre-test post-test control group design. But the Solomon for group design is actually the combination of the two. The combination of the pre-test only and then the pre-test post-test control group design. So in this design, the randomly selected subjects are placed into four groups. So there will be four groups in Solomon four group design, as the name itself, four group design. Then the first two of these groups are tested using the post-test only method, while the other two are tested using the pre-test post-test method. So you will see later on the diagram of that as we go on with the slides. So when we talk of experimental research, we're actually talking about characteristics. First, the variables. The variables that we control. It always contains dependent, independent, sometimes extraneous variables. Take note that the dependent variables are the variables being treated or the being provided with the treatment or manipulated, while the independent variables are the experimental treatment being exerted on the dependent variables. We also have the so-called extraneous variables, and those are the factors affecting the experiment that may also add up to the change of the behavior or the performance of the students. Another characteristics that should be considered is the setting, where the place you will do the experiment. Okay. As for the multivariable, when we talk about not single variable design, then we'll talk about that. So moving on, so those are the general things that should be considered. Let's take a look at through experimental group design. Let's try to simplify the things that I have mentioned a while ago. So for true experimental design, don't forget to employ randomization. That's the difference between the true and quasi-experimental research and even to the pre-experimental research design. In order for us to consider the normality of the population. Okay. So randomization, don't forget to employ randomization when we do experimental research. And then for quasi-experimental research design, without proper randomization, and it lacks rigorous statistical scrutiny. Pre-experimental design, it lacks in several areas of the true experimental criteria. No random selection is also being conducted or done. And then you will only employ single group that receives the treatment. There will be no control group compared to the other designs. But one of the advantages of experimental research design is very practical. Practical. You can actually use this for if that for your action research, but not necessarily for your thesis. Then it set the stage for further research because there is a possibility that the pre-experimental design would not be possible for true experimental design, and then the result would be different when you do quasi-experimental design or true experimental design uh, out of the result of the pre-experimental research design, or same title, but the only difference is the randomization and then the design that you would be using. and you would be comparing two groups, because there is a possibility that though there is a difference, significant difference in the performance of the students in one group, but when you compare that to another group, then result would be different, because pre-experimental design has lower validity. So take a look at it. There are three again, as I mentioned a while ago. As for quasi, there are also three non-equivalent control group, the time series, and then the multiple time series design. And as for the pre-experimental design, we have the three again, one-shot case study, one group pretest post-test study, and then the static group comparison study. If there is only one dependent variable that can be manipulated, then a single variable design is used. If there are two or more dependent variables, and at least, take note, at least one can be manipulated, then a factorial design should be chosen. So that's the difference between the factorial design, but still experimental, not true experimental research design. But sometimes there is a possibility that you can do a quasi-experimental design because you are actually considering two or more independent variables, and you can manipulate one, but you did not use randomization. So it's still a factorial design, but you did not use randomization. Most of the time in factorial design, it is true experimental design. So you have to consider true experimental design. Only that there are two or more independent variables. But take note, uh, remember, at least one can be manipulated. At least one. It could be two or three. And there are should be two or more independent variables. As for educational research, we always use the single variable. But for PhD, you can make use of two or more independent variables. But make sure that you can manipulate one, right, to make it factorial design. Single variable designs, pre-experimental, true, quasi. Low degree of control for pre, high degree of control for true, and medium degree of control for quasi-experimental design. And these are the types again, the designs. So let's take a look at it now simply. For one-shot case study, one group is exposed to the treatment, and then a post-test is given. Identify that group, then you expose them to the treatment, then give them the post-test. The first one is administered at the beginning, and then the treatment, and then the second at the end. So there will be pre-test and post-test. But the only difference to the others, yung not employment of, we are actually here, since experimental design, we are not employing randomization to identify the participants who belong to the control group and the participants who belong to the experimental group. And static group comparison design, at least two groups are involved. After one group receives a treatment, all groups are post-tested. Okay. Take note, one group only will receive the treatment. Even if you have three or more groups or two or more groups, there will only be one who will receive the treatment, but all groups will be provided with the post-test. Okay. So for static group comparison design, take note now there should be at least two groups that are involved. But remember, there should only be one group under experimental, and the rest of the groups would be under control group. And all groups are post-tested. So that means they will be provided with the post-test or validated post-test that you have prepared. Now, the true experimental design compared to pre-experimental or random quasi-experimental design, it should be randomly assigned. The participants should be randomly assigned in order for you to have a higher control of the internal validity as well as the external validity of the result of your research. So there should always be a control group to compare the results of the subject in the experiment with other subjects of similar status that have not been exposed to the treatment or to the intervention. So take note, there should always be two groups in order for you to compare the results of your research. The post-test only control group design, the pre-test post-test control group design, and then the Solomon 4 group design. I would propose Solomon 4 group design if you want. As of the moment, nobody in Roosevelt made use of this design, the Solomon 4 group design. But if you want to finish your paper in a SEM, then you might want to consider the pre-post-test control group design. If you're allowed to use randomization in identifying the control group and the experimental group, or the subjects and or participants of the control group and or experimental group. So let's take a look at the post-test only control group designs. Here, the participants are randomly selected. Take note always when you talk about true experimental design, random selection should be utilized in order for you to assign the participants from the control group and experimental group. So due to randomization, the two groups are statistically equal. That's why we were able to consider the threats to internal validity. No pretest is given because, as you can see, this is post-test only control group design. And one group receives the treatment. So the procedures, let's take a look for step number 1. What you need to do is to identify, of course, the control group and experimental group through randomization. The aim is to control the subject characteristics threat to internal validity, but there will be no treatment that will be provided to the control group, and then treatment or intervention or strategy will be provided to experimental group in order for you to observe any possible change on the dependent variable. And then post-tests will be provided to both the control and experimental group in order for you to measure the degree of change. Take a look at these. So group number one, we have the pre-test. Okay. Treatment will be provided and then post-test. So here in the pre-test post-test, obviously, the two groups will be provided with the pre-test and the two groups will be provided with the post-test. But only one group, particularly the experimental group, will receive the treatment. Let's take a look at the steps. So same, randomly assigned the first group and the second group, all the control group and the experimental group. Pretest will be provided to both to measure the degree of the dependent variable before the treatment. The dependent variable is actually the experimental group, and then the treatment will be provided post-test. The treatment will be provided only to the experimental group. There will be no treatment to the control group, and then post-test will be provided to the two groups in order for you to measure the degree of change. And sometimes statistically, we're actually talking about the significant difference. Okay? There should be significant difference in the performance of the students. Analysis that should be utilized, t-test for independent samples, right? How do we do that? We try to determine if there is a significant difference between the average scores of the groups, 02 and 04. As you can see here, 02 and 04. Is there a significant difference? Because this group received the treatment while this group did not receive? Are the participants in these groups perform better compared to this group? This group? If yes, is it significant? Because there should be significant difference. You can also compute gain scores. Okay, gain scores. No, did the performance of the experimental group improve, or did the performance of the control group improve or not? So that's the gain score. So for Solomon 4 groups, if you understood the first two groups, the pretest only and the pretest and post-test control group design, then all you need to do is to combine the two designs to have Solomon 4 group design. Okay. Uh, takes the effect of pretest and post-test sensitivity into consideration. So this is a combination, as I mentioned a while ago. Again, randomly selected. Okay, as you can see here, combination of the two, as we can see. The groups 1 and 2, the pretest post-test design, okay, pretest and post-test design, and the groups 3 and 3, post-test only control group design. So the first and the second groups are retested. The first and the third groups are exposed to the treatment, and the second and the fourth groups are taken as control groups. All four groups are post-tested. All you need to do in order for you to understand is to go back to the two research designs and then combine them. Example, third graders are randomly assigned to one of four groups. Therefore, there are four groups. The knowledge of language is measured in groups 1 and 2. Groups 1 and 3 are given a special study on the language learning. So that's the treatment, special study. When the special study is over, all four groups are tested, or they will be given post-test. Okay, so the analysis that we need, statistical treatment that we need, one-way ANOVA. In order for you to test the differences in the four post-test, the post-test of 02, 04, 05. The effects of the pre-test can be analyzed by applying t-test if you want, because we are actually considering the two designs, no? Pre-test only and post-test only, and then pre-test post-test control group design. So you can make use of the t-test as I mentioned a while ago. But when you combine the four, you can make use of one-way ANOVA to determine the differences of the post-tests of the four groups. The effects of the treatment can be analyzed by applying a t-test to the means of 05, as mentioned a while ago, and 06. 05 and 06 here. Subject maturation can be analyzed by comparing the combined means of 01 and 03 against 06. Now, 01 means of combining 01, the means of 01 to 06. When we talk of subject maturation, this is actually one of the internal threat to validity. We'll go into that, to the details of that. Just focus on the research design and the differences among them.